Okay, so now we go back to our waveforms. So this is our full AM waveforms where M is less than 1. So from there are number of parameters that we can associate with our signal from this waveform. Like before we learn about EM and EC, yeah. So now it's like Vmax peak to peak, Vmin peak to peak, Vmax positive, Vmin positive, Vmax negative, Vmin negative. So from all these parameters, we can also calculate our M differently. So wait, I'll admit some of your friends to join first. Okay, so so this ping line is actually our EM signal. So before modulation, yeah, it's centered around the axis at 0. So when we modulate, it will be the whole signal will be shifted and shifted above. So that's why instead of here and before Vmax positive is EM, for example, it will be EC plus EM. So the same thing for negative. Yeah. So negative inverted of our EM, and then it will be shifted by minus EC. Okay, so this after modulation, instead of EM and minus EM, it becomes EC plus EM for Vmax positive, and the minus is, and the Vmin positive is EC minus EM. Okay, so the negative for the negative cycle is just the opposite, the inverse. Vmax negative is minus EC plus EM. Vmin negative is minus EC plus EC minus EM, or EM minus EC. Okay, so we'll do some exercises on this to get clearer picture. And we can also use trapezoid diagram to calculate our M. Yeah. So if you look, I'm not sure whether you have seen already the basic common laboratory, the AM experiment. If you did, then there was this procedure that you have to calculate and analyze your waveform using oscilloscope. Okay, and then when you connect to different points from your board, then you will be able to view the trapezoid diagram. So actually, this trapezoid diagram represents the Vmax peak to peak and Vmin peak to peak. Yeah? This shape. And we can also obtain M from the amplitudes of our sidebands and carrier signals. Okay. But you need to remember that M equal to EM over EC is only applicable for full AM, the most fundamental AM type. Okay, let's look at this one exercise, our first exercise. An AM modulated signal is generated using VMT equal to 3 cos 2 pi 10 to the power of 3 t. And it modulates the carrier signal VCT equal to 10 cos 2 pi 10 to the power of 60. First, find the modulation index. Then find the upper and lower sideband frequencies and also the bandwidth. Then the ratio between sidebands, carrier, and carrier amplitudes. And finally, the maximum and minimum peak-to-peak voltages of the modulated signal. Okay. So we are given our VMT and VCT. We can extract information from these two signals. I'll share first my solution. Okay. So here our EM is equal to 3 and our EC is equal to 10. Yeah? Our FC is 10 to the power of 6 or 1 megahertz. Our FM is 1 kilohertz. So you just take values of EM and EC, you get M equal to 0.3. And then for the upper and lower sideband frequencies, we already know our FC and FM. It's just FC plus FM for upper sideband and FC minus FM for lower sideband. And bandwidth is 2 FM. When USB minus LSB, which is the highest minus the lowest frequencies, we get our bandwidth, which is equal to 2 kilohertz. And the ratio between sidebands and the carrier amplitudes. So our sideband is EM over 2. Divided by EC is 0.15. And Vmax to peak and Vmin peak to peak. Vmax peak to peak is 2 times EC plus EM. Vmin peak to peak is 2 times EC minus EM. Okay, so got 26 and 14 volts. So these are the simple calculations related to full AM signal. Okay, any questions so far? No? Do you have other class at 2? No. Okay, good. I'm the only one who has class at 2 then. I've capstone lab. Okay, you have class at 2. Yes, yes. Okay. Let's just finish some other exercises.
Oh, doctor, can you repeat how to get bandwidth?
Bandwidth? Okay, bandwidth.
It's 2 times FM.
Okay, bandwidth is actually the highest, like I said, is the frequency range, difference between highest frequency and lowest frequency. So if you look at the, let me go back, our spectrum here, our highest frequency is FC plus FM. Lowest frequency FC minus FM. So if you minus this one, you get 2 FM, right? So it's equal to 2 FM, which is upper sideband minus lower sideband.
Oh, okay, thank you, doctor.
All right. Other question? No? Okay, another exercise. Okay, this time instead of giving you VMT and VCT separately, we give you AM signal. So we have our AM signal. Okay, you can notice we have one component at the carrier and then other components at upper sideband and lower sideband. And then it's also given your equation of carrier, which is your 500 cos omega CT. So the same, here is that's our carrier. Find the envelope equation, message signal,
in
modulation.
My younger and more vulnerable years, before everything seemed awry. Welcome back to Project Example. Welcome back to pain. As a child,
Okay, is that all right? Okay, let's look at the solution. Like I said, envelope equation is equal to EC plus VMT. So we already know our VMT. Okay, we don't. We know our EC is 500. Okay, VMT we don't know, but we know that it's equal to EM cos omega MT. Okay, so in this question, the values of FC and FM are not given. So we just represent it as omega MT. But we can get the value of EM from our VAM equation. We know that sideband's amplitude is half of our modulating signals amplitude. So we just time 2 lah, 100 become 200. So our envelope equation is 500 plus 200 cos omega MT. And then our message signal, it's called 200 cos omega MT. It's very direct. And modulation percentage is EM over EC. So EM is 200, EC is 500, so 0.4. In percentage, it's 40%. And spectrum of our modulated signal. So when it says spectrum, you need to be aware. So it's amplitude versus frequencies. So for full AM, we have 3 components: the FC, FC plus, and FC minus FM. And then you have to also label the amplitudes for each component. At omega C is 500, at the sidebands is 100. So you need to label all this correctly, don't miss them. Okay, if the values of frequencies are given, you need to put the values. So typical mistake, students, they got confused between spectrum and waveform. Okay, so again, waveform is voltage, amplitude versus time. Spectrum, amplitude versus frequency. Okay, so let's look at the last, I think, exercise. So right now, you're given information from a trapezoid diagram. So it says peak to peak 15 and 9 volts respectively, FM 1.5 kilohertz and FC 100 kilohertz. Okay, find math equations for the message carrier and modulated signals, modulation index, spectrum of the signals with amplitudes, and then modulated signal in time domain. Okay, so now, apart from equations and spectrum, the question also asks you to modulate the signal in time domain. Okay, so you are given from the trapezoid diagram 15 and 9, which are the values of Vmax peak to peak and Vmin peak to peak. Okay. So Vmax peak to peak is 2 EC plus EM, and Vmin peak to peak 2 EC minus EM. So when you solve these two, you got EC equal to 6 and EM equal to 1.5. Okay. So we are given FC and FM. So from these values, we can produce our VMT, message signal, is equal to 1.5 cos 2 pi 1.5 kilo T. And then VCT is 6 cos 2 pi 100 kilo T. Okay. Modulated signals is EC plus VMT cos omega CT. Okay, if you notice this equation is C plus VMT cos omega CT. If you notice, the frequency cos omega CT does not change, right? But the amplitude here, instead of EC, it has additional plus VMT at the amplitude part. Okay, so and that's why it's known as full AM. Okay, so frequency, the angle part is not changed, but the amplitude is changed. So we just substitute all the values, EC and VMT inside this equation. Okay, next, spectrum. Okay, the frequencies and also the amplitudes. And then our waveform in time domain. So the most, you can, when you are asked to sketch for the waveform, you need to start, and you can start from the Vmax peak to peak, Vmax peak to peak plus and minus, and Vmin peak to peak plus and minus. Okay, so this is Vmax, this is 7.5, and then Vmin positive 4.5, Vmax negative in the minus 7.5, and Vmin negative minus 4.5. So from these values, you can start sketching your envelope. Okay, the positive and negative envelope, and in between the envelopes you can sketch the high frequency components. Okay, so that's the tip to sketch your waveform. All right, so this is your homework, your exercise. So you're given two conditions. You try to plot the waveforms for these two conditions. First is where our EC is equal to EM, which is 6 volt, and 2 is when our EC is equal to 6 volt and EM is equal to 8 volt. So please, each of you try to plot the waveforms. Then we continue this Wednesday, inshallah. Okay,
Doctor, do you mind? Doctor, do you mind going back to example 2.2? I just want to see the solutions again. Thank you, Doctor.
2.2, this one. Is it?
Yeah. Thank you. I just want to get the solution again.
Doctor, can you repeat again the steps on how we going to plot the graph?
What? Which graph?
The last one, the spectrum.
Spectrum. This one. Spectrum.
Sorry. The waveform. The waveform.
Okay. So the solution. Okay. Can I go to the other slide? Wait. Let's wait for our friend to take note.
Doctor, I'm done. Thanks.
Okay,
Doctor.
then good.
You can proceed.
Right. This one. Is it this one?
Yeah, the last one.
Okay.
Yeah.
All right. So we know our EC is 6. Okay, you are given here from this equation. Our EC is 6. Our EM is 1.5. So you plot on your graph, on Vmax peak to peak, EC plus EM, and then this one Vmin positive, which is EC minus EM. So this one you got 7.5, Vmin positive 4.5. Okay. So this is the positive envelope. Okay. Between you sketch like a sine signal between 7.5 and 4.5. Okay. And then for the negative cycle, it's just the inverse. So the below one is minus in bracket EC plus EM. Okay.
Doctor, I have another question. Regarding the shape of the modulated carrier signal or whatever. Means the typical AM modulation should look like this, right? With the the vast squiggle shape. Then how does the over modulation? You mentioned that over modulation got that that thing like cross each other, right? So what does it actually means?
Okay. Later, when we move to the envelope part, the envelope detection, you will understand why.
Oh, okay.
It's related to detection part. There will be loss of data. Okay, if you notice here, up here is EC plus EM, Vmax peak to peak. Okay, so this is your Vmax peak to peak. Okay, so right. Okay, so up here is this is Vmax positive. Okay, so here is this one is EC plus EM. So for Vmax negative is minus EC plus EM. So this Vmin negative is minus EC minus EM. Up here is EC minus EM. Okay, here EC minus EM. The negative one is just invert, put negative sign, so it's minus EC minus EM. So you get here is minus 4.5, up here 4.5. So for the negative cycles, you will plot between minus 7.5 to 4.5. You put, so you will, from this peak-to-peak values, peak-to-peak voltages, you will be able to plot the negative and positive envelopes. And then in between the envelopes, you just catch higher frequency signals like this. And the amplitudes of your higher frequency signals follow your envelopes. Okay.
Doctor, I have another question. This may sound like I didn't pay attention, but the top plot and the bottom plot, how are they related?
These two?
Yeah.
Yes.
Yeah,
they're related.
How are they related?
Because this is actually the spectrum. Frequency versus, voltage, amplitude versus frequency. The same signal, but it's just voltage versus time. Because up here, actually, from here you can get your period, right? For example, from here to here, this is your where is it? Okay. This is one period. This is your TM, right?
Yeah.
Okay. So from this period, you'll be able to get your FM, which is 1 over TM is 1 over FM. Okay. So this is your DC plus VMT. This is one period, which is a TM. Inverse of TM is 1 over FM. And here you get your frequency. And then this one, you use FM up here, FC plus FM. So here they are the this is in time domain. So the peak amplitudes here actually you consider you add the voltages from FC, FC plus FM, FC minus FM,
Oh, so the top envelope refers to the 0.75. That plot, is it?
Okay, and here one cycle here. Sorry, one cycle here. This is one cycle, right? This is your TC. This is equal to 1 over FC. And the amplitudes, they are varied, and the amplitudes actually the sums of, and the varied amplitudes are sums of amplitudes from FC, FC plus FM, FC minus FM. But the whole waveform here can be represented using AC plus VMT. Sorry, that's quite terrible. Times cos omega CT. Okay. So this part is your envelope, and this is your high frequency. So this is the time domain, the M signal.
Oh.
But for example, I don't want to give you direct information on your FC and FM. I just will give you waveform. You should be able to find FM and FC from this. You can also find FM and FC from the waveforms. Like I said, okay, this one cycle is TM. You can get FM from this one cycle of FC, of TC. Sorry, you can get your FC. So they are related. The same signal, exactly the same signal. It's just how you represent them. Spectrum is V over F. This is spectrum. Waveform is V over T. This is waveform. And the relationship between them is F equal to 1/T. Yeah, exactly the same signals. It's just how you represent your signals, that's all.
Oh, I understand. One more question, Doctor. The last one. It means the signal cannot assume any frequency between the three lines. For the
Cannot assume frequency between three lines.
Between the three lines, yeah. Means like continuous distribution.
Okay. Can. Of course you can. Yeah.
Or is this not discrete plot lah?
Because this is, we assume only one fundamental frequency of our FM. But if I give a range, if my VMT is not only one frequency, it has VM, FM 1, 2, 3, then there will be bandwidth, and my VM bandwidth. Then your this one also has, you know, like range as well.
Oh, I see. Oh, how about in between the spaces? They don't assume any frequency. You cannot.
You have spaces between this range and your FC, but bandwidth you need to calculate from the minimum frequency until the maximum frequency, the difference between the two, if you have range.
Okay. Thank you, madam. Thank you.
Okay, welcome. Okay, this is your homework. Where's okay. You can see it still. Can still see it in the homework question. You plot waveform when EC equal to EM 6 volt, and then EC equal to 6 volt, and EM equal to 8 volt. And this is when your M equal to 1, the first one, and the second one, your M larger than 1. Okay. Can you, do you understand your homework? Okay, all right. Okay, so I prefer Zoom lah, because it's quite user friendly and can do many functions. But let's see, inshallah, I have to upgrade, not use the free version. Okay, so see you this Wednesday, and then we can discuss our homework. So that's it. See you again, and Assalamualaikum. Good afternoon. Have a good day. Bye.
Okay, thank you, Dr. Bye.
Bye-bye. Assalamualaikum.